In this lab, we were able to find the amount of excess charge on an ordinary object by placing knowledge of Newton's second law in electric force. The goal was to find the amount of excess charge on one piece of charged Scotch tape. Two pieces of tape were connected and pulled apart repeatedly, causing electrons to jump from the tapes and making them positively charged. The sign of charge was determined by holding one piece of tape near a pen that was rubbed against a piece of fabric, making it negatively charged. Since the tape was attracted to the pen, we know that the tape is positively charged since opposite signs attract. Since the two pieces of tape repelled one another, we know both pieces must be positively charged since like signs repel. The magnitude of the charge was determined by floating one piece of tape over the other, measuring the distance between them, setting the electric force equal to the gravitational force, since the top tape is levitating and not in motion, and finally solving for Q. When two objects, like the tapes, are pulled apart, electrons are transferred. In this case, the electrons jumped off of both pieces, causing them to become positive. Here are the properties displayed as I went in more depth on slide 2. Using the top piece of tape modeled as a point charge, the summation of the force done by gravity in the negative y direction and the electric force done by the bottom tape on the top tape in the positive y direction equals 0, since the top tape is not in motion. The magnitude of the force of gravity is F equals mass times negative 9.8 meters per second squared, and the formula for the electric force is shown. D is the distance between the two tapes when placed on top of one another, which was measured to be 0.0281 meters. The magnitude of the gravitational force was set equal to the electric force, and Q was solved for. Each tape is represented by a particle. Some assumptions are no air resistance, the tapes acting as point charges at the center, and the tapes being directly on top of one another. The magnitude of the charge on one piece of tape was calculated to be 4.147 times 10 to the negative 7 coulombs. Here, the orange arrow represents the electric force on the top tape done by the bottom tape, and the green arrow represents the gravitational force on the top tape. The magnitudes of these two forces are equivalent. Here are the calculations explained previously done in GlowScript. The link to the full code is included in the description of this video. What if electrons had a positive charge and protons had a negative charge? What would change about the observations you made with your tapes and other charged objects? If electrons were positive instead, the tapes would become negatively charged, since they are losing the positive charges. They would still repel one another since they'd both be negative, but they would also repel the pen, which was negative. They would still attract other neutral objects since the neutral objects would be more positive and they would act as a positively charged object. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come in contact with your hand or other objects? Since electrons jump from one object to another by contact, it was important to not let the tapes touch any other objects, since this could cause electrons to transfer back to the tape, and that would decrease the levitation distance, which would ultimately make the calculations and results inaccurate.